Now, in last lecture, we just learned about the overview concept related with embedded system. Now we start with our syllabus for embedded system. That is first unit of AIDS student branch, Introduction to Embedded System. So concept related with embedded system. So just we go with a definition. An embedded system is a specialized computer system with a dedicated hardware and software. Uh, Designed for a specific function found in everything from smart watches to the cares characteristic by the task specification real-time operating resource uh, constraints. It may be a consider the power and energy. So what we say that a general the embedded system, it is a combination of software and hardware and which use for the dedicated application and purpose of the embedded system. So basically, it is a combination of software and hardware, uh, which is used for the uh, specific task. It may be related with home security system. It may be used in related with logistic. It may be used in a security purpose. It may be used building management. Everywhere there are a number of application related with embedded system. So we go with one by one. So basically, starting with that embedded system, first we understanding the characteristic of an embedded system. That is, which characteristic need to be present when we go to designing and develop a embedded system. That parameter we have to consider for the designing purpose of any embedded system. So first is the performance specific task. You know that it is a very important parameter, the performance specific task. So the embedded system performs some specific function or task. Whatever the task we have to uh, whatever the task they given, and we have to develop a system for a specific task. So it should be a perform and concentrate on that specific function and whatever the task. Just taking one example, suppose we want to concentrate on automatic lock of door or automatic lock of any vehicle. So the main specification, it concentrate of the locking parameter at a real time. When the switch will be a push, the system should be a off, and switch will be a push, the system should be on. So it is real. So it is a performance specific task. The system should be a performance oriented, low cost. Second parameter, and which considers that the price of embedded system is not so expensive. So the it should be have a less amount of cost. So it is can be a utilized everywhere and design with lower cost of. So low cost is the second characteristic of embedded system which will be a consider. The third characteristic is time specific. It perform the task within a certain time of frame, right? So whatever the time period is given for completion of the task and giving the some output at a certain time, it should be a provide the specific output at a given time. So we say that it is a real time of operation. It's like it is very important parameter. So we know that number of application which will be a depend upon the time specification. Is like a smoke alarm, right? Fire alarm. Generally, we say that. So when the smoke detector will be detect the fire, uh, the, at the same time the spinger will be the water spinger will be on. So it can be whatever the uh, um, harmfulness will be occurs because of this fire, that will be a remove. So it is a real time operating. Second, in most of the medical application, we know that every second we need to be update and depend upon that situation of patient. It should be a take the action. So it need to be a work on the real time. So embedded systems should be a perform their operation for a given task, whatever the given time period of that particular system. So it's time bounded or time specific operation. Next is a low power. So it does not require much power to be operate. With small amount of power, very small amount power, it can be a work properly, efficiently. Because of low power, it can be utilized in anywhere. With battery supply, it can be operate with minimum number volt. It can be operate is like 5 volt, 3 volt, which can be a possible. So, may number of application will be a work with a low power consumption, right? High efficiency, that will be important. The efficiency level is so high. So whatever the number of atoms will be done or a number of action will be done by the system, it should provide constant and efficient efficiency for each and every task. For each and every task, is like just we taking one example. uh, uh, a door lock. Suppose in a day there will be 100 times there a door will be open and off, but in 101 time it should be open and it should be off at same time of efficiency, and same time of same performance should be present. It not be a degradation of the performance. So it have should have a high efficiency for working their application or whatever their performance. Next, manual user interface, minimal user interface. There should be a minimal user interface. The system require less user interfacing and are easy to use. So considering with that parameter, it should be a do it selfly. There will be a requirement of minimum user interface, right? It can have a take need to be interface with other system and easy to synchronize with other system. There is no requirement of interfacing. Last is the less human um, interventions. The very less intervention that may be we say that it may be related with automation parameter. The system it can have a capability to do and take their own decision and execute their operation. So that will become less human intervention or interference. We say that related with that. So the error capability is very less. Having a capability to work more. The best example is related. We say that currently the auto vehicle, that will be a best example. Then AI based driving, that will be having own decisions. So the car will be take decision where the traffic condition related the obstacle will be a present, and whatever the action will be near. Airbag is one of the one example of that one. It can selfly take the decision about that. Then stable, it should be a high stable. It does not change the frequently, most fixed, maintaining stability. Whatever the parameter will be decided and performed by the embedded system, it should be a stable. It not be a variation. There is no need to be a toleration, because the toleration will be a comes after the certain point in a error. So it should be a stable at every condition, whatever the condition of the input and the processor parameter, it should be a provide the output should be a stable. So whatever the decision taken on that one, it should be a good performance base. Then high reliability, it performs tasks consistently well. So reliability should be increased, and it's also depend upon the specific performance task, efficiency and stability. The reliability should be a increase, and that will be a concentrate on the more parameter. So these are the basic characteristic of embedded system. That is a one point. So we learn about the what will be introduction to embedded system. So embedded system is a combination of hardware and software which used to do a specific task uh, for conducting the number of operations. So characteristic are not, of embedded system is nothing but a performance parameter. We also say that that parameter need to be a present in a system. So it can be a define the working of that embedded system. So performance specific task, low cost, then time specification or specific, low power, high efficiency, minimum user interface, less human intervention, high stability, and high reliability. These are the important characteristics of the embedded system. After that, there are some figure of merits for the embedded system we have to consider. So the figure of merit, we generally say that the it defines the performance parameter of system. Now, first parameter characteristic we learn, which say that this parameter need to be a present in a system, and if this parameter will be a present, we have to evaluate and calculate the performance of that system and the performance calculation is totally depend upon the figure of merits, right? So the figure of merits is for the embedded system. So what will we say that figure? The figure of merits for embedded system are the key performance merits used to be evaluate and compare the different design based on their specific function of requirements. So it calculate the performance parameters related with the embedded system, and it verify by the different ways. So unlike the general purpose computers, the embedded systems are designed for the dedicated task, making characteristics like power consumption, size, real-time performance criteria. So depend upon number of things, whatever we learn in characteristic of embedded system, we verify this in a figure of merits. So first figure of merits considering with embedded system is a performance. So we know that if the performance is 100%, that and that time reliability of that system will be increased. So this is a often and measure in terms of processing speed, throughputs, and the latency. So performance is calculated in the uh, parameter like measuring the terms of processing speed. What are the speed of that execution? What time required to execute particular task, uh, and what the speed of that execution, that throughputs, how they handle the input and output parameters, and what are the latency will be present on that the performance. So that all things will be a consider to calculate the performance of that system. Next, power consumption, energy efficiency, that will be a very important parameter related with the embedded system power consumption. So we know that the characteristics say that it should be operate at very low power. So the very less requirement of power and execution should be a reliable and stable. That is important. So power consumption is a very important parameter to uh, uh, for checking the performance of the embedded system. Energy efficiency. What is the capacity of that one? Right? It's like that. Just we taking that when we charging one of the laptops for 1 hours, it will be a work up to the 8 hours. Right? That will be carrying out the efficiency of that energy. Then cost, the cost should be a less minimum cost, the system having the minimum cost for their designing. Size and weight, it will be a matter, it should be a minimum size and weight should be a less. Then reliability and stability, these are two important parameters. Whatever the number of tasks they doing, it should be a provide the same performance at the number of tasks, whatever the time specification given, you should be able to provide the output at that time sufficient. Whatever the performance they needed, you should be able to provide the performance. The efficiency should be throughout constant end to end working. So that increase the reliability and stability, real time capability. Whatever the mm, time period given for a particular task execution, it should be performed within that time, right? So that will be important. So just we taking one example that self-driving or auto-driving will be, or AI-based driving say that suppose there will be an obstacle will be a present for a particular um, uh, about the vehicle. So the vehicle should be a take decision. So how much distance will be a consider to break the system, or whatever the uh, action need to be taken. If some dashes or some accident will be occur, the airbag should be open at the same time, but it save the life of the humans. Next, there are number of times. A simple example in daily life we observe that. So water tank fill in, automatic water tank fill up and on and off of motors. So when the water level will be decreased below of the certain level, so the motor should be on. After the filling of water, the at certain level the what motor water motor which should be going to off. So it is a real time operation. Whatever the application will be a work real time. In medical purpose, it is very crucial application where we require real time application. At a certain time they have to produce the output, and the doctors will be take the decision for the handling the patients. So these are the some parameters which used to be identify the performance of system. So figure of merit sets are very important uh, consent which verify the performance of the system, embedded system, and decided that whatever the characteristic will be included for the designing, it will be satisfied and not be a satisfied. So it include performance, power consumption, energy efficiency, the cost, size, weight, reliability, stability, and the real-time capability. Right. So exam point of view, you explain this with some of the example that will be a need to be a consider, because the example will be help to more understanding the parameter. Right. So today we learn about the basic concept related with embedded system and characteristic of embedded system, what are the parameter they consider, and then we go with a figure of bits. Now in next lecture we start with the actual element of embedded system. Now we today stop. Anything.